Hi and welcome to the video training of Elixir. In today's video training we will be discussing processes. In Elixir all code runs inside processes. Processes are isolated from each other. They run concurrent to one another and communicate via message passing. Processes are not only the basis for concurrency in Elixir, but they also provide the means for building distributed and fault-tolerant programs. Elixir's processes should not be confused with operating system processes. Processes in Elixir are extremely lightweight in terms of memory and CPU, even compared to threads are used in many other programming languages. Because of this, it is not uncommon to have tens or even hundreds of thousands of processes running simultaneously. In this video, we will learn about the basic constructs for spawning new processes, as well as sending and receiving messages between processes. Spawn. The basic mechanism for spawning new processes is the auto-imported spawn function. So let's try this, how it works. Let's enter the Elixir interactive mode and let's define a spawn function 1 plus 2 and we got an PID. PID means process ID. Spawn takes a function which it will execute in another process. Notice spawn returns a PID process identifier. At this point, the process you spawned is very likely dead. The spawned process will execute the given function and exit after the function is done. So let's define a variable called PID and execute the same statement that we did above. Okay, we got a compiler. I mistyped spawn. It is SPAWN. This time I got another PID and now I can run the process.alive function to check if that process is still alive or not, and I got false. So you will likely get different process identifiers than the ones we are getting in this guide. We can retrieve the PID of the current process by calling self. So if I type in self, this will return me the process ID of the current process. And if I say process.self, process.alive, and I pass in self, I'll get true. Processes get much more interesting when we are able to send and receive messages. Let's look at how we can send and receive messages. We can send messages to a process with send and receive them with receive function. So let's try send self colon hello comma world. Okay, I got hello world. Receive do hello comma message. World underscore message equals won't match and I got world, which was sent through the send command. It's a send function that was sent to the self process and it was sent in the hello variable. Value was world. So we received that message using the receive function. When a message is sent to a process, the message is stored in the process mailbox. The receive block goes through the current process mailbox, searching for a message that matches any of the current given patterns Receive supports guards and many clauses such as case. When a message is sent to a process, the message is stored in the process mailbox. The receive block goes through the current process mailbox searching for a message that matches any of the given patterns. Receive supports guards and many clauses such as case. If there is no message in the mailbox matching any of the patterns, the current process will wait until a matching message arrives. A timeout can also be specified. Receive, do, hello message, and message after 1000, nothing after once. Okay, end. So the receive function checked the mailbox of the current process and gave us an output nothing after once. A timeout of 0 can be given when you already expect the message to be in the mailbox. Let's put it all together and send messages between processes. So let's define a function and assign self to that variable parent. Now let's spawn a function send parent hello self end. Expected reserve word end. Okay. Okay, we forgot the closing bracket. Okay, we got the PID. Now we going to use receive do hello PID got hello from inspect PID end. So we got the string got hello from PID 0.129, which is the one that we got earlier. The inspect function is used to convert a data structure's internal representation into a string, typically for printing. Notice that when the receive block gets executed, the sender process we have spawned may already be dead, as its only instruction was to send a message. While in the shell, you may find the helper flush quite useful. It flushes and prints all the messages in the mailbox. So if I say send self, comma, hello, and I call flush, I get hello, okay. So let's look at links. The majority of times we spawn processes in Elixir, we spawn them as linked processes. Before we show an example with spawn link, let's see what happens when a process started with spawn fails. Spawn function raise oops and okay, we got an error because we raised an oops error at runtime and we got this error value.do apply. It merely logged an error, but the parent process is still running. That's because processes are isolated. If we want the failure in one process to propagate to another one, we should link them. This can be done with spawn link. So if I want to see the PID of self process, use the self. Now let's link the spawns using spawn link function raise oops end. Okay, it kicked us out of the interactive mode, so shell process exited with reason and exception was raised. So both the processes were destroyed and the interactive mode is restarted. As you can see, we re-entered the mode and it says Ctrl C to exit. Because processes are linked, we now see a message saying the parent process, which is the shell process, has received an exit signal from another process, causing the shell to terminate. IEX detects the situation and start a new shell session. Linking can also be done manually by calling process.link. We recommend that you take a look at the process module for other functionality provided by processes. Processes and links play an important role when building fault-tolerant systems. Elixir processes are isolated and don't share anything by default. Therefore, a failure in a process will never crash or corrupt the state of another process. Links, however, allow processes to establish a relationship in case of failure. We often link our processes to supervisors, which will detect when a process dies and start a new process in its place. While other languages would require us to catch handle exceptions, in Elixir we are actually fine with letting processes fail because we expect supervisors to properly restart our systems. Failing fast is a common philosophy when writing Elixir software. Spawn and spawnLink are the basic primitives for creating processes in Elixir. Although we have used them exclusively so far, most of the time we are going to use abstractions that build on top of them. Let's see the most common one, called tasks. Tasks build on top of the spawn functions to provide better error reports and introspection. So let's look at tasks and how they work. Task.start and define a function, one-liner function, raise, oops, end. Okay, we got an error saying terminating. We got a process ID as well, and at the end we got arguments. Instead of spawn and spawnLink, we use task.start and task.startLink, which return OK PID rather than just the PID. This is what enables task to be used in supervision trees. Furthermore, task provides convenience. Functions like task.async and task.await and functionality to ease distribution. Okay, let's look at state. We haven't talked about state so far in this guide. If you are building an application that requires state, for example, to keep your application configuration, or you need to parse a file and keep it in memory, where would you store it? Processes are the most common answer to this question. We can write processes that loop infinitely, maintain state, and send and receive messages. Let's write a module that starts new processes that work as a key value store in a file named kv.exs. So let's go to the terminal and create a file called kv.exs. Okay, let's define the module, def module, call it kv, do def start link. This is the function we are defining, start underscore link, and it further uses the task.startLink function, and it passes function loop percentage brackets and end. Okay, that's the end of this function. Now let's define a private function, def p loop map do, receive do, and let's call get key caller and assign it to send caller map.get, and parameters are map and key. Loop map. Okay, now let's put key into value. Assign loop map dot get dot put map key value. Okay, end of receive function, and end of the private function, and end of the module, def module. Let's save this file and let's move. Note that the start link function starts a new process that runs in the loop function. Starting with an empty map, the loop private function that waits for messages and performs the appropriate action for each message. We made loop private by using def p instead of def. In the case of a :get message, it sends a message back to the caller and calls loop again to wait for a new message, while the put message actually invokes loop with the new version of the map with the given key and value stored. Let's give it a try by running iex kv.exs. Okay, let's run kv.exs. Okay, pid equals kv.start link. Okay, send pid get hello self. Okay, now run flush and we will got nil. At first the process map has no keys, so sending a get message and then flushing the current process inbox returns nil. Let's send a put message and try it again. This time let's send a put message instead of get message. Hello self. Okay, now send the get message and now flush. We got okay. We didn't got world. Okay, I forgot to use to enter the message here. Put hello world. Now if we flush, we get world as a value which was entered into hello, and when we printed out the value of hello from the task, we get the value which we added in the first statement. Notice how the process is keeping a state, and we can get and update the state by sending the process messages. In fact, any process that knows the PID above will be able to send it messages and manipulate the state. It is also possible to register the PID, giving it a name and allowing everyone that knows the name to send it messages. Process.register PID KV. Okay, we got true, and if I send kv get hello self and flush. I should get world here. Using processes to maintain state and name registration are very common patterns in Elixir applications. However, most of the time we won't implement those patterns manually as above, but by using one of the main abstractions that ship with Elixir. For example, Elixir provides agents which are simple abstractions around state. PID equals agent dot start link function percentage and agent dot update PID function map dot put map hello world and okay. Now let's get the value by calling the agent.get function PID function map, and this time we are going to use map.get and get the value of map hello and should get world. A column name option could also be given to agent.startLink and it would be automatically registered. Besides agents, Elixir provides an API for building generic servers called GenServer, tasks and more, all powered by processes underneath. This was all about the processes in Elixir. If you liked this video, don't forget to subscribe to my channel. You can also email me at umehmood@gmail.com. You can visit my Facebook page or my LinkedIn profile, and I'll be more than happy to help you. See you next time with a new topic in Elixir.